Alright, so today we're going to go over a MacBook Pro that has a sensor issue. This is going to be an annoying thing to try to film. Firstly, because the phone is going to ring, but not only because the phone is going to ring, but because it's going to take forever to boot it up to start the sensor test. So what I'm doing here is I'm going to boot into ASD, and I'm going to boot into the EFI version of ASD. The reason I'm booting into the EFI version of ASD is because while the older OS versions of ASD, which is the Apple Service Diagnostic, those versions allowed me to see exactly which sensor failed. On newer machines, the ASD now says, a sensor has failed. Thank you. Very fucking helpful, Apple. But I digress. So what's going on with this machine is it's working really slowly. When I move the mouse, it skips all around the screen, and the fan is always running at a really high temperature. So I'm going to go on error stop, actually I'm going to go on error continue. You can barely see that. And the board is not really screwed in. I just didn't screw it in so I could show you what's failing. So I'm just going to deselect all, and then I'm only going to select the sensor test. We're going to run the sensor test and try to figure out what's going on. Because remember, whenever you have a machine that's running stupidly slow, not like hard drive kind of slow, but where it feels like it's running at 1 megahertz, not even hertz, it's usually a sensor issue. So over here, we're going to see that there are a few sensors that are failing, right? You see how it says failed? Now we have lists on the screen of the sensors. So I'm just going to read them because you can't see that, and I honestly don't feel like fucking with the camera and getting up right now because I'm very tired to zoom in on the screen. So it says S2 camera proximity. Sensor is reading below the low limit. TA0P. Input airflow sensor is reading below the low limit. And let's just scroll up because there are some other sensors here that are also fucked up. CPU proximity. Sensor is reading below the low limit. And we also have charger proximity reading below the low limit, S2 camera proximity, and input airflow. So now let's try to get an idea of what's going on with the schematic. So now that we have this information, I can turn this off. And we can look through the schematic and try to get an idea of what's going on with the sensors and why the machine is running really, really slow. So from here, I'm just going to go over to the schematic and the diagram, and let's try to figure out what's going on. So open broadcaster, switch. All right, so now we're in the sensor diagram here where it's showing you all the different points where the SMC is talking to different parts of the computer. So if I were to search here for something like CPU proximity, what do you know? CPU proximity sensor, inlet sensor. This seems to be very, very relevant to all the sensors that are failing. And if we look at this, you can see that there are different sensors here. So it says detect proximity temperature and blah, blah, blah. This is U5800, and this chip is going to take all the different sensors and allow those different sensors to talk to the SMC on this data line. So as you can see here, we have alerts. But what's actually allowing it to talk to the SMC, which is what's dealing with all the sensors here, you can tell that from the Apple Service Diagnostic test. It'll tell you that everything's talking to the sensors. Are you able to see everything? Curious if Open Broadcaster is properly resizing this. It's not. You fucker. Okay, let's re-go over that. Fucking Open Broadcaster, man. Actually, not Open Broadcaster. Fuck the idiot who misconfigured it who's sitting in front of the screen running Open Broadcaster. It's funny how we blame the computer when it's actually us so often of the time. So see over here, SM bus, SMC1, SO, SCL. See this thing over here? This is a bidirectional data line and a bidirectional clock line where the SMC is going to talk to this chip. So let's just get an idea here. So over here it says CPU proximity, and here's the thing that here's the reason that I'm jumping to this area in this chip. The reason I'm jumping to this area is because it's not one sensor that failed, it's numerous sensors. So you have numerous sensors on the board, and all of them failed. Really? Like all 4 of those sensors are doing the exact same thing, which is reading below the low point. It's not that it can't read one sensor's too high, one sensor's too low. You have 3 or 4 sensors that are all reading too low. So what I'm going to do here is I'm not going to look at each individual sensor. I'm going to try to figure out what those sensors have in common. And the same thing is true if you're troubleshooting any type of studio gear that is dual channel or stereo. If you get a compressor in to fix and both channels have distortion, you're not going to look at the left channel circuitry and then the right channel circuitry. You're going to try to figure out what they have in common. Are they using some stereo feedback circuit? Is the power supply that powers both channels bad if it's a piece of equipment that has one power supply for 2 channels? This is some of the stuff to think about, is what does it have in common? And here, all those sensors have in common this chip, and they're all talking on the same data line. So see, that SMC data line goes to... It goes to the CPU, so CPU sensor. It was talking about camera something, or S2 camera sensor. It goes to the webcam. It goes to the SMC. And it goes to these other chips that are going to read information. So let me just open the board view software over here. We're going to open up the board view software. All right, so let's take a look over here. So we have C for component. I'm going to hit C for component. Now I'm going to type, wow, you see how shitty Windows 10 scaling is? Can you believe this shit? Look, up here, the way I just had it, you saw what it did, right? You saw that. I'm not losing my mind. So right up here, everything was virtually invisible. But then when I clicked it and dragged it over here, everything became standard font size. But when I drag it back up there, it doesn't turn into being invisible again. I don't get it. Microsoft has no fucking idea how to deal with scaling or high resolution displays. It's a real joke. It's so dumb. So U5800, U5620, and J4002. So let's try to get an idea here of what is going on, and let's see if we can get a hint from the motherboard as to why this is not working. So J4002 is going to be the webcam connector. U5800 is going to be over here, and U5620 for chipset current is going to be over here. So now what I'm going to do is I'm going to plug the microscope camera in, and I'm just going to pull the board out of the machine so that I can just take a look at it and try to inspect what's going on. Now, there are a lot of things that I can do to try and figure out what is pulling the data line down. I mean, I can inject. First I'd have to see if the data line is being pulled down by something. I've done videos in my basic electronics video series on a data line, what is a data line, and how do pull-up resistors create them. So if you're not familiar with how these data lines work, if the word pull-up resistor kind of confuses you, I'd highly suggest that you stop watching this video, that you pause it, and in a new window in your browser, you look over my guide to basic electronics video series that I've done, and look up the video I've done on a data line, because that's going to be very helpful for you here, or else none of this is really going to make sense. So there are a lot of things I could do to figure out what's pulling down the data line, but the first thing that I'm really going to be interested in is just taking a look at it and just using some common sense to see if I can figure out what's going on here. So let's go ahead and do that. So I'm going to switch over to the microscope camera, assuming that it lets me. I hit F2, and beautiful. So the first thing that talks to, let's see. So J4002, which is the webcam connector. This is the webcam connector, and I think that webcam connector looks pristine. I don't see anything wrong with that webcam connector. I think it's great. Now the next is going to be U5800, which takes information from the CPU temperature sensor, the BMON, thermal, inlet, and all the other crap. And let's just take a look at U5800. U5800 is looking pretty good over there. I have no complaints about U5800. So now let's look at U5620, which talks on that same data line, which is for chipset current. So U5620 is going to be, let's see, it's on that SMC data line, and let's see what that looks like. And that's oh, well, what do you know? It looks like complete shit. Now this may work if I fix some, if I clean it and get rid of the corrosion. I have to ultrasonic this board anyway, and since I have a great selection of boards here with that chipset on it that don't look like complete garbage, what I'm going to do is I'm going to take that chip off of a donor board and put it on this one. And once that's done, let's see what happens with our sensor issue. Let's see if we have to do any further research or if we're good. So I'm just going to go to the donor pile here, rip that stuff out. I turn the JBC on. I turn my fume extractor on, and let's go for it. Yeah, it's some pretty nasty looking shit right there, isn't it? That's what water does. It screws things up. And as usual, this is just one of many, many machines where they're like, I didn't spill anything. I didn't spill anything. What you mean I didn't spill anything? I didn't spill anything. Oh, man. take you off. Let's restore that to that over there. This. Some slight gentle scraping so all the old nasty corroded up solder gets sucked up into my iron. And get rid of that excess over there. There's still way too much in the middle. That's way too much. It's one of those things that I'm just never going to get right. Oh well. Beautiful chip. Way too much solder under it. I know, I know. Bad habits die hard. I know, that looks like crap, doesn't it? Absolute shit. Okay, we're all connected. This thing over here looks a little better now. You look like shit, so you can get off of my motherboard. And we... Some good old common sense. Whoops. Let's make this. Now we get that capacitor from this board right next to me. The solder on that resistor bothers me, but at 0201 this iron is probably not good enough to make it as nice as I'd like. Also, what did I do to the ends of this? Ay, ay, ay. Oh, well. Oh, well. I can live with it. So let's see what I get when I put this back inside of a computer, shall we? What do you think? You think it'll still be pulling my data line down, or do you think I'll be good to go? Well, one way to find out. Now, I can run ASD, sure, but honestly, I can tell if it'll be pulling the data line down, because if it stops doing that shit where the fan is running really fast, I'll know that the sensor issue has been resolved. Drives me nuts when people replace the trackpad and don't bother making sure that it's tight. Like with that, you know that bullshit on when you can like click and then click again? It's like double click in one trackpad with the airs. I hate that shit. If you're gonna replace the trackpad, fucking do it right. How do you not even notice that when you're testing it, that every time you click it double clicks? Okay. So say okay, do this. Yoink, yoink. Okay, I'm plugging in just the bare minimum stuff that I need here, just to make sure that I actually fix the issue. I need the screen so that I can see what's going on. I need the trackpad and keyboard because there is a sensor inside the trackpad and keyboard, inside the trackpad, I should say. And without that palm rest temperature sensor, the fan will run non-stop, and I also won't be able to select tests. I need the screen so I can see things. I need the left I/O board because that has the FinStack sensor on it. And with that, I don't care about Wi-Fi or webcam or any of that shit right now. I'm just going to turn it on. Now you have to wait for RTC reset to finish on the Air. Every time you unplug the battery and the charger at the same time, it's going to turn on, off, on, off, on, off if it's the 2013, 14, or 15 editions. So we do this. Okay, we're going to plug in ASD. And we're going to run EFI ASD. The fan is STFUing. That's nice. Good little air. Good little air. Come on. I'm tired. I want to go home. Don't fuck with me. Testing sensor. And CPU proximity works. What do you know? Passed. Now, of course, it's going to have to get ultrasonically cleaned because, fuck if I know how many other chips corrosion got under, but that. There's no way in hell I'm going to let this leave just because it passed. This has to get ultrasonically cleaned. Not so much for the flux. I would ultrasonic it for the flux, but the main reason is I don't know if there's liquid under the CPU. I don't know if there's liquid under the SMC. I don't know if there's liquid under the RAM. I can't see that with my eyes. So even if the board itself looks perfectly clean, I don't know if I actually did my job. So yeah, this is an example of how to solve a sensor issue. This is an example of how to use the Apple Service Diagnostic to solve a sensor issue. Now again, you would have to be fucking blind to not find this. I used to work with somebody who would say everything looked perfectly clean, and then you would open it and you would just see this big green patch of shit, like this huge green patch of water damage, and I would just be thinking like, yeah, how did you miss this? Otherwise, like, really great guy, really great, really great tech. But for some reason, he would always miss these huge patches of green shit and say that it was clean, and we would give giving stuff back to people that was like failing, and we'd say bring it back in, and there would be this lovely little patch of water. But yeah, obviously you don't need a schematic or a board view or even much logic to figure out what's wrong with this. It was very obvious. But sometimes it won't be obvious. Sometimes it will be a sensor, as in the case with some of the newer Retinas. I did a video recently on humbling a Retina board around August, or it was September or October of last year, about some sensor issue. I couldn't see the sensor with my eyes. Like, I couldn't actually see it. Like, once it was pointed out to me, I could see it, but if you told me that, look at this board and tell me what's wrong with it, I genuinely would have not seen that sensor without it being pointed out to me. I know it's there now that I see it, but before seeing it, it's like, what the hell? There are going to be a lot of times when you can't physically see the sensor that's damaged, and there are also going to be lots of times where maybe it's just damaged internally, not externally, so you don't know where to look. But this software is going to help you, know where to look. And what sucks is that, of course, like with everything in life, Apple doesn't make it available to independent repair shops. So, yeah, don't ask me where to get this. That is your journey. That is your journey with Google and to figure out where this stuff comes from. But that's it for today. And as always, I hope you learned.